Okay, so without hesitation, let's begin our lessons for the final chapter for this semester 2, where we are going to have a look at the questions for introductions towards the D blocks elements. So let's have a look together, shall we? Okay, so as usual, we are going to start off with the objective questions for these chapters. So let's have a look together at the questions. Now, question number 1 sounds like this. Which of the following statement is correct regarding of the transition elements? A, all transition elements exhibit oxidation state from +1 to +7. So it is actually incorrect. Only manganese are able to have oxidation state as high as +7, not all. So A is incorrect. B, scandium to zinc are transition elements in the periodic table. Actually, no. Scandium and zinc is not transition elements because they only have one ions, okay, and then their d orbital is either empty or complete filled, so it does not obey the definitions of this transition element. Then C, stability of the oxidation state of transition element depend only on the electronic configuration. No, it depends on certain other values other than the electronic configuration. They also depend on the standard electrode potential carries by each of the transition element itself. Finally, chromium 3+ and manganese 2+ ion are stable in aqueous solution. So when we say stable, that means that they cannot react under acidic air, okay? So in here, if you use the equation O2 plus 4H plus 4Mn2 plus give 4Mn3 plus 2H2O, so E0 will be negative 0.28, and then 4Cl3 plus 2H2O plus give O2 plus 4H plus 4Cl2 plus, E0 is negative 0.82. So about how we get this overall equation, you may refer back to the videos that I've already explained thoroughly in details of this chapter, so you can refer back to that. So the best answer in here is D. Okay, so with that realization, let's go to question number 2. Transition element is suitable to be used as catalyst because of most of the time, as I already explained earlier during the early video, we know that why is it suitable to be used as a catalyst? Because number 1, catalyst can making use of its variation in the D block MTD orbitals to either exhibit various oxidation state or they have this active site to cause a temporarily bond in here. Okay, so the 2 reasons what makes transition elements suitable to be used as catalyst is because it can exhibit various oxidation state and element has active site to form bond with it. So the best answer is D, 2 and 4 only. Then we go to question number 3. Among these elements exhibit only one oxidation state. So which one exhibit only one? So in here we have, as I explained in the question 1 just now, scandium and zinc are actually not transition element even though they are D block elements, because they have only one oxidation state, which is +3 and +2 respectively, and then their D orbital for scandium is empty, for zinc is complete filled, so that is why they can only exist as a one simple ion. Okay, so the best answer in here is 1 and 3 only, C. Number 4, which of the following physical properties are that of a transition element? So a transition element must have relatively high melting point, boiling point, high density, and good electrical conductivity. So the best description that describe all of them, the best that suits to all of the description in here is C. So A is trying to explain about the melting point of the group 1, while B is trying to explain the melting point of the probably non-metal because it has a weak electrical conductivity. And then D is usually carbon, as in diamond, because it has a too high melting point as it is a giant covalent structure. Okay, so that is what A, B, and D, each of them trying to explain, but C describe the properties possessed by the transition elements. Then we have number 5, a crystalline salt Z was dissolved in water and then aqueous solution of sodium hydroxide. It was added to the presence in an excess. A white precipitate was formed, which turned to brown on exposure to the air. Which of the following could be the Z? So in here, when you add NaOH, Fe2+, which is supposedly to be a green solution, turn to almost like white precipitate, even though there is a little greenish inside there, but it's almost like white. And then when exposed to air, so it will be able to oxidize from iron 2+ to become iron 3+, according to the equation, O2 plus 4H plus 4FeOH2 give 4FeOH3 plus 2H2O. So that is how you form the brown precipitate. So the brown precipitate is due to the presence of the FeOH3. Okay, so the best answer in here is D. Then we go to question number 6. An aqueous solution containing a mixture of copper, iron, and lead-2 ion was treated with excess aqueous ammonia. What precipitate was left in this reaction? So you have to understand the nature, which of them can easily form precipitate. So when you added copper ion, iron, and lead ion in excess ammonia, so only copper will form a deep blue solution, while the while Fe2 plus and Pb2 plus will form a green and white precipitate respectively. So with that, it shows how the iron 2 and lead 2 will form will react with the ammonia. Okay, so if this one, if you want the video later, I do have the video with me. If we have extra time, I will get into that. Okay. Okay, then number 7, platinum 4 chloride combined with ammonia to form compound which coordination number of the platinum is 6. A formula unit of one compound contains a cation and 2 chloride ion. What is the formula of this compound? So the question already stated clearly, because in here platinum has an oxidation state +4, while it carry a 2 Cl minus. So it means that this complex contain a +2 charge. So therefore, if there are 2 Cl minus that act as a ligand, so which give the coordination compound to be a PtCl2Cl2, Cl2 as a 2 Cl as a ligand, and 2 chlorine as a free moving ion. So this is how the question describes the whole thing. Okay, so when we say that its coordination number equals to 6, since 2 is used as a dative bond, that will give platinum 4 more empty spaces for it to coordinate. So it can coordinate to become PtNH344Cl. Okay. Okay, so this is for number 7. So number 8, the blue precipitate of copper 2 hydroxide dissolved in excess ammonia aqueous solution to form a dark blue solution. So which of the following formula correspond to the blue precipitate and the dark blue solution? So this one, you must know that the blue precipitate is due to the formation of the CuOH2, while the deep blue solution is due to the complex of the ammonia, which is CuNH342+. Okay, so this is what happens when you first slightly add a little copper, then followed by excess ammonia inside the copper in here. So you'll get to observe that observations in here. I also have a video for that, and I think I show it during the lesson number 4. Okay, lesson number 4 of this chapter. So you can always browse back the video that I've already uploaded on my channel. So see what is actually going on inside there. Okay, so with that, that is for question number 8. Then we go to question number 9. A green precipitate of nickel 2 hydroxide dissolved in excess ammonia to form a light blue solution. Which of the following equation correctly responds for the formation of the light blue precipitate? Okay, or light blue solution, actually, light blue solution. Okay, so the light blue solution is due to the formation of the complex of NiNH362+. Okay, so similar to copper, nickel can also dissolve in excess ammonia aqueous solution. So with that, it's formed the hexaamine nickel 2 ions. Okay, so teacher, how do we know when is nickel has this what coordination number equals to 4 when coordination number equals 6? Usually element those behind of the transition element, for example zinc, for example copper, most of the time they will exceed +4. Then +6 is for the earlier one, such as for scandium, titanium, vanadium, chromium, manganese. They usually have a coordination number equals to 6 in there. Okay, so similar to nickel. Nickel also is considered as the early part of the D block element. So that is why they also form coordination number equals to 6. So that is why at the end of the result, you form a light blue solution, which is NiNH362+. Then we go to number 10. Which of the following best explain why vanadium 5 oxide can be used as a catalyst in contact process as industrial method to prepare large scale of the sulfuric acid? Okay, so this is due to vanadium can form variable oxidation states. So in here, the steps that corresponds to the correct reactions that happens within the contact process is first, SO2 is oxidized by vanadium 5+. Then you form vanadium 4+. Then this vanadium 4+ will act as an oxidizing agent, so oxidizing the 4+ to become 5+. Okay, so that is how the interchanges in here take place, and making use of the variable oxidation states. This is specifically for this contact process. So as You have to know, this one you have to know. Okay, so that is how you describe for question number 10. Then we move to question number 11. In which following properties does the transition element has the highest oxidation state? So this one you have to calculate one by one. Okay, so Kl2Cl4 oxidation state is equals to +8. NH4BO3 oxidation state of V is equals to +5. K4FeCN6, Cn itself is -1. So 6 times -1 plus 4. Okay, so that at the end of the day, you get the metals transition element to be a +2 oxidation state. And last but not least, KMnO2, K2MnO2. Okay, so this is manganese oxide. So the oxidation states for the manganese in here is the +2. So the highest, as you can see in here, will be A. Okay, then number 12, aqueous nickel 2 nitrate contain complex of NiH2O6 2+, which is green color. Addition of EDTA to the solution causes the solution to become purple color. Which of the following statement can be concluded by this observation? Okay, so we can imagine that what happened when these solutions of the nickel, okay, which first contain NiH2O6 2+, when you add it to ethylene diamine, it turns to purple in here. So is it because A, ethylene diamine is a stronger ligand than water, which is definitely yes, okay? So purple solution is maybe due to the formation of the complex NiNH2, yes, because nickel has a coordination number equals to 6, so you can easily form these bidentate complexes by using nickel, and the stability constant of NiH2O6 2+ is greater than that, which is wrong. If not, then NH2CH2 NH2 cannot even react or dissolve in water. Okay, so C is wrong, and then finally D, wavelength absorbed by the complexes is lower than that of the NiH2O6, which is correct. Okay, okay, so how do we know that it's correct? Because it shows purple. So when we show purple, while the NaH2O is showing green, it indicates that NiH2O6 absorbs a higher wavelength. So that is why how we prove this one. So always remember, from the wavelength, from the shortest to the longest, okay, from the shortest to the longest, shortest is the purple color, then longest is the red color. So you should be able to distinguish which is which color inside here. Okay. Okay, so with that, that is for number 12. Then number 13, the reaction between iron 3 oxide, iodine, and sodium peroxide disulfate ion is described in the mechanism below. So mechanism, you have two Fe3 plus 2I minus, give 2 Fe2 plus I2, which is a slow step. Then you have 2 Fe2 plus 2 S2O2 minus, give 2 Fe3 plus SO42 minus. Okay. So which of the following statements are correct in regards to the reaction above? Number 1, iron 3 acts as the catalyst for the reaction, which is true. Okay, so it acts as a homogeneous catalyst, heterogeneous, homogeneous or homogeneous. So iron 2 is a homogeneous, not hetero, so 2 is wrong. Number 3, overall reaction can be written as 2I minus plus S2O2 minus with SO42 minus, which could be correct because from S2O2 minus to SO42 minus, the E0 value is very positive. That means the easily being reduced. And the rate of reaction can be expressed as rate equals to I2 Fe2 plus, which is correct. So the best answer that describes all of these is 1, 3, and 4, C. Okay, so that is how we are going to solve for question number 13. Then we go for number 14. FeCN6 minus absorb blue and violet light. Which of the following diagram represent correctly, and how does this absorption take place? So in here, we have to know what type of ligand that we are dealing with. The type of ligand that we are dealing in here is CN. So CN is a very strong ligand. When you have a strong ligand, it will cause the complex to split up greater among each other. So that is why there is a reason of how the ligand will influence the arrangement inside the FeCN6 3-. So first of all, you need to know what is the oxidation state of FeCN6 3-. So the oxidation state of FeCN6 3- is +3. So the configuration will be this what 3D5 okay. Because initially you have 3D6 for S2. After you remove 3 electrons, you become 3D5 only. So you should have 5 electrons rearranging themselves. And because cyanide is a very strong reagent, it causes the repulsion pair to become smaller. Okay, so it is because the electron has been paired up to maximum. So when it's paired up to maximum, no more electron can occupy inside low energy level. So that is why the best answer that describes all of this is B. Okay, so that is for number 14. Immediately we go to number 15. Which of the following best explain the action of transition metal act as a catalyst, heterogeneous catalyst? Number 1 is have a fixed oxidation state, which is wrong. Yes, many. Number 2, it depresses the enthalpy change of the reaction. Okay, so it increases the enthalpy change, which is does not. Catalyst does not alter the enthalpy change of reaction. It will only alter the rate. Number C, it supplies energy to increase the rate of effective collision, which is not to say supply energy. You cannot supply energy, okay, in the form of that catalyst. And then number D, reactor and catalyst are different phase, which is sometimes correct. Okay, so which is correct. Okay? So the best answer for number 15 is A. Then we go to number 16. A complex salt with a coordination number 6 has the formula CiNH3A H2O has the comparison by mass of 13.89 is equal. Sorry, 13.89 is equal, correct? 13.27 is nitrogen, 3.79 is the hydrogen. Which of the following statements are true regarding the complex salt? So the ratio between nickel to nitrogen to hydrogen, as described in the equation, will be 13.98, 13.27, and 3.79 respectively, which should be divided by their mole. So once you divide it by their mole, 0.236 divided by 1, you get 1. 0.97 divided by 2.36, you get 4. And then 3.79 times 10 power of 3.79 divided by 0.236, so you get 16. So at the end, the ratio is n equals to 8, y 4 times 2 equals to 2 times 2, sorry, 2 times 2 equals to 4, and 3.79 16 divided by 0.236. So the ratio of the n equals to 8, h equals to 2. So therefore, this is the diamine, plus there is one complex name is the tetradiamine aqua 2 ion, nickel 2 ion. So the best answer that describe all these is actually 1, 2, 3 only. Okay, so that is for question number 16. Then we go to question number 17. Which of the following blocks element can form the complex of MCl4-A? Now you must understand the M has a oxidation state of +3. Therefore, scandium and copper can form +3. Copper and zinc are more stable as a +2 oxidation. Then you have no choice but to memorize a bit. So the best answer in here is 1 and 3, not 1 and 2, 1 and 3. Make sure it's CU or not. Macam bukan macam bukan CU. Sorry, it's titanium. Titanium, sorry for my mistake. It's titanium, scandium and titanium. So 1 and 2, yes. Okay, then number 18, 25 centimeter cube of 1.0 mole of aqueous solution of potassium manganate was reacted completely with 50 centimeter cube 0.2 solar hydroxide of iron 2. Write the complete equation for the reaction. So first of all, you have to calculate the mole of KMnO4. So you calculate 0.1 times 25.0, you get 0.693. Oh, sorry. 2.5 times 10 power of -3 mole. Okay, then number of mole for the iron in here, 0.25 times 50.0 divided by 1000, you get 7.5. So therefore, 1 mole of manganate react with 3 mole of the iron, since the ratio in here is 1 to 3. So now, in terms of exchange, if you understand the principle behind the correct balancing equation, when something give 1 electron, then when something accepted 3 electrons, when you do the lowest common multiple, you said 3x plus y give 3e, because somehow in some way they are about to cancel off each other. So in here, the whole thing in here will be multiplied by 3. The whole thing in here will be multiplied by 1. Since the changes in here is from 7 to minus 3, you get plus 4. So after the reaction in here, manganese has a plus 4 oxidation state. Therefore, the valence electrons from this case is plus 4. Okay? So hopefully you can understand on how to solve the questions like this. You have to calculate the mole, then you compare the stoichiometric coefficient for it so that you get the changes of the oxidation state in here. Okay, so that is for number 18. Okay, then we go for number 19. The half reaction of the dichromate 6 ion are given below. So you have Cl2O72 minus plus 14H plus 6E minus give 2Cl3 plus 7H2O. In an experiment, 45.0 centimeter cube or 0.4 mole per decimeter cube of aqueous solution P2 plus has reacted with 15 centimeter cube or 0.2 aqueous solution of potassium dichromate. What is the change? What is the charge carried by P after the reaction? Okay, so this is very similar to the previous question just now. So you have to calculate both mole of the dichromate and also M2 plus. So mole of the dichromate is 0.0015. So mole of the M2 plus is 0.009. So since the mole of the M2 plus oxidized by 1 mole of Cl2O72 minus is 0.009 divided by 0.0015, you get 6. So the ratio is 1 to 6. Okay. So if you look at the half equation, Cl2O72 minus plus 14H plus 6. Okay, in the whole thing of the dichromate, okay, you just multiply by 1, isn't it? Multiply by 1, isn't it? While the whole this one, you multiply by 6, isn't it? Because you have 6 electrons, so you must balance. So that is the key of what I try to tell you in here is if chromium oxidized by, if chromium oxidized the other species by plus 6, okay? So while the other is reduced by something, so that is why you see here, when you reduce only by 1, because the ratio is 1 Cl2O7 to 6 electron. So in here, your mole of the Mn plus must be 1. Understand what I'm trying to say? So for example, if you have 14 plus 14H plus, 14H plus 6E minus plus MnO4 give 7H2O plus Mn2 plus, and then the other one will be M2 plus Mn plus, so plus E minus. Okay, so in here the whole thing multiply by 1, while in here the whole thing multiply by 6. Do you see that? So since the iron in here is ratio 6, so the ratio in here is 1 to 6. So in other words, this M2 plus oxidized by 1 oxidation state. So that is how you get the plus 3. So the best answer in here is 8. Okay, and last but not least, which of the following statement is true about FeNH2, CH2, CH2, and H2, 3 plus? Number 1, ethylene diamine is a bidentate, which is correct. Okay, and then shape is a trigonal planar. No, shape is octahedral. Coordination number of iron is 6, which is also correct. And then finally, complex ion of FeNH2 is more stable than FeH2O3. So the best answer in here is 1, 3, and 4 correct. So the answer in here is C. Okay. Okay, so I guess that is all for our lesson for today. We are going to continue our lesson tomorrow. Okay, then I'm going to explain the rest of the structure, and then plus a few the rest of the objective, and then plus a few structure questions. Okay, so with that, I end my video lesson for today. So that's all. Thank you very much.